Alright friends, this is been a while, hey, but this is also a bit of a gamble. Since my computer kind of died, I had to download everything again, and this is a new app that I'm using to record. It's a new app that I'm using to kind of display with the camera, and it took me too long to figure out how to focus in the first place. But we're going to give it a shot and see how it goes. Let me know if something's weird or out of focus. It took me forever to focus it. So yeah, let me know how it goes. Now, also in other news, nuclear energy and society. This was tough trying to figure out because we're not going to get through everything. We're just not with the new government recommendations, etc. We have to cut some things, and I've decided to cut this unit to start. There's a lot of chemistry overlapped into it, so I figure, you know what, you're going to get kind of covered in chemistry, and there's not a lot of this next year, so I don't think it'll hurt you too much. But it's a bummer because there's some cool stuff if you want to look and see kind of what you're missing. This is chapter 7, page 316 is where it starts. You got some free time on your hands, then you should, to be honest, after today's lesson. But if you got some free time on your hands, then have a look, because it talks about atoms and isotopes in a different way than chemistry. It talks about radioactive decay, how things break down from a radioactive or unstable state, and the three different ways. There's more, but we talk about three different ways they break down. We talk about half-life. We talk about nuclear fission, nuclear fusion. Makes me sad. Fission, splitting atoms, lots of energy. Fusion, forcing them together to create a new element. Not a compound, not a molecule, but a new element. Two atoms create a new atom, not a, whatever you call two-atom molecule, yeah. The Earth can't, we, society, scientists can't figure out how to do fusion yet on a cost-effective basis for creation of energy, but that is how the sun creates its energy. Anyways, there, I just told you the unit. I'm such a nerd. Alright. Vibrations and waves. We usually have the first lesson back after kind of a test or what have you as pretty short, because we spend the class going over the test. Well, we're not doing that today, but it's still pretty short. Did you copy that down? Good. Vibrations and waves. Is this all on screen? No. Can't back up enough. Vibrations. That's what the title is. Vibrations. Use the notes. Let's take those down for a couple seconds. Okay, a vibration, this is in bold. This was usually a test question. Hint, hint. A vibration is defined as the cyclical motion of an object about an equilibrium point. Let's think about a pendulum. So a pendulum, like on a grandfather clock, I'm not going to look like that at all, but it'll be like tick, tock, tick, tock, tick, tock. And it's regular motion, right? Cyclical motion, it's regular motion. It's not like sometimes it hangs out over here and then it's just quick over there or whatever. It's like, and the equilibrium point is where it would be at rest. Created by the transfer of energy through a medium. A medium is a solid, liquid, or a gas, something that energy can transfer through. It creates a mechanical wave. When you see a wave, the particles are vibrating against each other. How effective a medium is at transferring waves depends on the structure. Depends on its mechanical structure, its molecular structure, its density, and its temperature. Different in gases than it is in solids. The more rigid a medium, the more efficient it is at transferring a vibration. You'll notice like how sound travels over water. You've been in a boat and you can hear people talking on a dock and you can almost not even see them, but it sounds like they're almost whispering to you. The surface of the water is more dense than the air. It helps pass it along. Mechanical waves last longer, go faster, and farther. A medium is said to be elastic if it returns to original state when done vibrating. Think of an elastic band. If you pull it, stretch it, let it go, goes wherever it goes back to its regular shape. An elastic is elastic. It's just the intro, my friends. That's it. There aren't even any like examples for me to go through with you. What even is this? First day back after what seems like forever of recording lessons, and this is all you get. I apologize. All right, you take care now. Bye-bye.